Welcome to our deep dive into the world of machine learning in transportation. I know you're super interested in this, and I think we found the perfect starting point.
Oh, yeah.
Machine Learning in Transportation
Okay.
by Dayala, Katai, and Malik,
Mm-hmm.
published just this year, 2025.
Wow, so it's brand new.
Brand new, covers a ton, from algorithms to actually coding this stuff in MATLAB and R.
It's a really good choice. It's got a very practical approach and focuses on real-world stuff.
Exactly. And going through it, I found this technique called comedoids clustering that caught my eye.
Uh-huh.
Apparently, it can group things, like states, based on traffic data, even when the data has like categories and words, not just numbers.
Really?
Yeah. Imagine finding patterns in traffic safety across all the states.
Oh, wow.
More targeted improvements, that's the kind of impact this could have.
Yeah, that's a great example. One of the biggest things that separates machine learning from regular statistics is that it can handle these complex real-world situations with all sorts of variables and categories.
So it's less about explaining why and more about predicting what will happen.
Yes, precisely. And the book goes into this difference. While traditional statistics are great at explaining those relationships, machine learning wants to build those models that can really forecast outcomes, even if we don't fully understand all the reasons underneath.
Okay, so that's the big picture. But how does this work in practice? The book talks about two types, supervised and unsupervised learning. Are they really as different as they sound?
They definitely each have their own style. Think of supervised learning like teaching a student with examples and clear answers.
Oh, okay.
You feed the algorithm input data and the outputs you want.
Uh-huh.
It learns those connections to predict stuff in new situations it hasn't seen before.
So if we wanted to predict traffic congestion using past traffic patterns, real-time sensor data, even weather, that'd be supervised.
Absolutely. You're giving it those known conditions and the congestion levels that go with them, so it learns and can predict future scenarios.
Got it. And unsupervised learning, is that where things get a little more mysterious?
You could say that. In unsupervised learning, we hand the algorithm data without labels. Let it explore and find hidden structures on its own, like giving a student a puzzle and watching how they put it together.
Interesting. So less about specific answers, more about discovering those hidden relationships.
Right.
Can you give a transportation example?
Sure. Imagine using it to analyze traffic flow from different spots and times.
Okay.
The algorithm could then cluster those locations based on traffic pattern similarities. It reveals hidden groupings without us predefining them. Super valuable for city planners, right?
That's fascinating. So we've got these different learning types, but what about the tools that make it all happen?
Right.
The book highlights all these algorithms, each with its own approach.
Yeah, like having a specialized toolkit,
Exactly. First up, K-nearest neighbors, or KNN. It seems to be all about finding those similarities.
You got it. Imagine you're classifying a new data point, say determining the risk level of a road segment based on its features. KNN looks at the K nearest data points, its neighbors, classifies the new one based on the majority class among them.
So it's like deciding what group you belong to based on who you're standing closest to.
Exactly. And it uses distance metrics, these calculations, to measure how close in terms of features.
Makes sense. Next up is naive Bayes. I'm still a bit hazy on this one.
It's all about probability, making those informed guesses. It calculates the probability of a data point being in a particular class based on its features. Could be used to predict accidents based on weather, road conditions, time of day, things like that. The naive part is assuming these features are independent, which simplifies things while still giving surprisingly good results.
So naive because it simplifies but still powerful.
Yeah, exactly. It's about that right balance, between complexity and actually making it work.
Right. Now, support vector machines, or SVMs, this one always seemed kind of intimidating.
They're powerful tools, but the concept isn't as complex as it might sound.
Okay.
Imagine trying to separate two groups of data points on a graph.
Okay.
An SVM finds the best line, or in more dimensions, a hyperplane that divides them, creates the widest gap between the groups.
So drawing a boundary that maximizes the separation sounds helpful for, like, classifying vehicles or traffic patterns.
Precisely. And what's amazing is they can handle nonlinear data by transforming it into a higher dimensional space where it becomes linearly separable.
Wow. They're real workhorses. Next, decision trees. These seem more intuitive, like flowcharts.
You got it. They use a hierarchical structure, like a branching flowchart, to make predictions. You start at the root node and follow branches based on the features until you reach a leaf node, the predicted outcome.
So if we were trying to find the best route for a delivery truck, based on traffic, delivery windows, fuel efficiency. A decision tree could help.
Exactly. It's like a series of if-then statements guiding the decision.
Yeah.
But they can get overly complex, prone to overfitting if you're not careful.
Yeah, overfitting. Is that when it's too focused on the training data and doesn't generalize well? Like memorizing answers without understanding?
Exactly. Like acing a practice test by memorizing but failing the real exam because the concepts aren't there.
Okay. Linear regression
Hmm.
brings back stats class memories.
It's the classic, but still widely used. All about finding that best fit line to describe the relationship between a dependent variable and one or more independent variables. Remember the equation y equals mx plus b?
Yeah, vaguely.
Okay.
So predicting traffic volume based on time of day and day of the week, perfect for linear regression.
Absolutely. Simple but powerful for those linear relationships.
And finally, artificial neural networks, or ANNs, always hear about these with deep learning.
ANNs get their inspiration from the human brain, layers of interconnected nodes like neurons processing and transmitting information.
So a digital brain tackling patterns and making predictions.
You could say that. They're good at those complex nonlinear relationships used in image recognition and stuff like that.
Wow, that's a lot of algorithms.
Yeah. There's a whole world out there.
But before we set these algorithms loose, the book emphasizes precking the data, like getting ingredients ready before cooking.
Absolutely. Even with the best algorithms, if your data is messy, your results won't be reliable. The book calls this data wrangling.
Data wrangling. Sounds intense.
It can be. It's a multi-step process. It starts with data exploration, examining the data, understanding variables, getting a feel for it.
So checking for missing values, outliers, making sure it's in the right format.
Exactly. Data cleaning is key here. Handling those missing values, outliers, any errors.
I can see why that's so important. The book also mentions data transformations, like giving the data a makeover.
You could say that. It's about making the data suitable for analysis. Sometimes converting categorical data, like words, into numbers the algorithms can use, or standardizing the data so variables are on the same scale for easier processing.
Like the example they give, transforming that region column in a traffic data set, assigning numbers to categories like South Atlantic.
Exactly. Tailoring the data to the algorithms and the problem you're solving.
What about data visualization? I bet graphs and charts are helpful here, right?
Data visualization is essential. Uncovering hidden patterns, identifying problems, presenting findings clearly, like turning raw data into a story everyone can understand.
Makes sense. Even the best algorithms are useless if we can't communicate those insights.
Exactly. Data visualization bridges that gap between complex computations and human understanding, makes machine learning accessible.
Now, dealing with complexity, the book talks about dimension reduction to simplify massive data sets. Sounds like we need a serious tool here.
Definitely. And one of the stars of this show is Principal Component Analysis, or PCA. It finds the most important features or principal components that capture most of the variation. Imagine a data set with hundreds of variables. PCA can reduce it to a smaller set of principal components that still hold most of the key information.
Like condensing a giant textbook without losing the main ideas.
Perfect analogy. And PCA can be used to visualize the data in a lower dimensional space. Easier to spot patterns and relationships.
Sounds super helpful, especially with those huge transportation data sets. The book mentioned it can help researchers focus on the key factors for traffic flow or safety without getting overwhelmed.
Exactly. PCA simplifies without losing the essence of what's happening. Like seeing the forest for the trees, getting the bigger picture without getting bogged down.
Great way to put it. Moving on to cluster analysis. This one's about grouping, right? Like soaring socks.
Exactly. It's about grouping data points with similar characteristics. In transportation, it could group travelers by their behavior, road segments by traffic conditions, even cities by their infrastructure.
So instead of separate things, we identify groups and patterns. Helpful for understanding complex systems like transportation networks.
Right. And there are different clustering algorithms. The book talks about k-means, one of those popular.
K-means assigns data points to clusters based on their distance from the cluster centers. Like finding the center of each sock pile and assigning each sock to the closest pile.
That's a great way to visualize it. But k-means has its limitations, especially when dealing with data that includes categories, what we call categorical data.
And that's where k-medoids clustering comes in, the one we mentioned earlier that can handle categories, the one used for traffic safety data across states.
Exactly. It's like k-means, but instead of using the average, it uses an actual data point from the cluster as the center, which makes it better for those categories.
So for each challenge, a specialized algorithm.
That's the beauty of it. Always evolving new techniques for more complex data analysis.
Now let's talk about the cutting edge. Deep learning, generating a lot of buzz these days.
Deep learning uses multi-layered neural networks to extract high-level features from complex data. They learn these hierarchical representations of data, pulling out more abstract and meaningful features at each layer.
So like those ANNs we talked about, but supercharged.
You could say that. Deep learning is great with complex data like images, audio, and text. It's a game changer.
And the book mentions this fascinating concept of transfer learning, where existing neural networks, already trained on massive data sets, can be adapted. Sounds efficient.
Transfer learning is a game changer, yeah. We don't have to train them from scratch, saving time and resources. It's like having a team of experts whose knowledge we can fine-tune for our needs.
Like that example in the book. Classifying images based on emulsion content in recycled materials using an adapted GoogleNet. Amazing how these networks can be repurposed.
It shows the power and flexibility of deep learning. Another interesting area is using long short-term memory networks, or LSTMs.
LSTMs, what are those?
They're a special type of recurrent neural network designed to handle sequential data like time series data. They remember patterns over time, making them great for predicting traffic flow, demand, even potential congestion.
So if we wanted to predict traffic changes over the next hour based on past patterns and real-time data, LSTMs would be the tool.
Exactly. That ability to capture those time connections makes them super powerful for forecasting.
It's amazing how deep learning is changing transportation. I can already see a future where it revolutionizes how we move in our cities.
It's an exciting time to be in this field.
Yeah.
The possibilities are endless. We're just scratching the surface of what machine learning can do for transportation.
This has been an amazing dive into the fundamentals. I'm ready to see how it's used in the real world.
Me too.
And in our next segment, that's exactly what we'll do. We'll explore how these algorithms are being used to solve real challenges, from optimizing traffic flow to predicting accidents, even powering the self-driving cars of the future.
I think it'd be cool.
I can't wait. See you in part 2.
See you then. Welcome back to our deep dive.
I'm so ready to see these algorithms in action solving real-world problems.
Yeah, it really is amazing how versatile machine learning is. It can tackle all sorts of transportation challenges, from smoothing out traffic flow in cities
Yeah.
to predicting potential accidents. It's making a real impact.
Speaking of traffic flow, that's got to be a prime spot for machine learning to really shine. I mean, who hasn't been stuck in gridlock?
Oh, it's a nightmare. Traffic congestion is a constant headache in those busy areas.
Yeah.
And machine learning can help us build smarter traffic management systems.
Okay.
Think about it. A system that analyzes those real-time traffic patterns,
Yeah.
predicts the congestion hotspots, and then adjusts the traffic signals to keep everything moving.
It's like a sneak peek at the future of smart cities. What about accident prediction? That seems like another place where machine learning can really make a difference, for safety.
Oh, absolutely. By using historical accident data, weather conditions, route designs, even social media trends,
Wow.
machine learning can pinpoint those high-risk locations and times, like having a crystal ball, but one powered by data.
So they're learning those patterns, those subtle things that often lead to accidents, and giving us a chance to step in and prevent them.
That's the idea. This information can be used to deploy targeted safety measures, maybe more police in high-risk zones, adjusting speed limits based on conditions, even public awareness campaigns.
So we're being proactive instead of reactive.
Right.
Amazing. And what about self-driving cars? I know machine learning is a core part of how they work.
Yeah, autonomous vehicles are a perfect example of how machine learning is transforming the game. They rely on those sophisticated algorithms to sense their environment, make decisions in the blink of an eye, and navigate through all those complex situations.
So they're constantly processing all that data from sensors and cameras, GPS, even car-to-car communication to understand what's around them.
Exactly. And they're always learning and adapting as they encounter new situations.
It's mind-blowing how complex it all is and how much progress has been made.
It's incredible.
Machine learning is driving us toward that autonomous future.
It really is. But it's not all about those flashy technologies like self-driving cars. It's also making things better in areas like pavement management.
Pavement management. I wouldn't have thought of that.
Right.
How's it used for that?
It might sound kind of boring, but keeping our roads in good shape is essential.
Oh, for sure.
And machine learning can make it more efficient. Imagine using models to analyze data from inspections, traffic loads, weather patterns, even the materials used.
So instead of those scheduled inspections that might miss problems, we can predict when and where the pavement will start to wear down.
Exactly. This helps agencies prioritize repairs, allocate those resources, and make those roads last longer, saving time and money.
It's amazing how machine learning can optimize even the most basic things. Shows how powerful it really is.
It does. And we're just getting started. As it keeps evolving, we can expect even more applications, changing every aspect of how we move people and goods.
So exciting. But with all this potential, we need to also think about the challenges, the limitations.
Oh, absolutely. Machine learning is powerful, but we can't forget about those pitfalls. One of the biggest challenges is making sure the data used to train these models is fair and unbiased.
So if a model is trained on data that doesn't reflect the real world, it might make predictions that are off or even unfair.
Exactly. Like if a traffic prediction model mainly uses data from rush hour, it might not do well predicting things during off-peak times or those special events.
It has to have a good mix of
Right.
scenarios.
Garbage in, garbage out.
Exactly. What about data privacy? With all this data collection and analysis, how do we protect people's information?
Oh, it's critical,
Yeah.
especially in systems that gather sensitive data about where people go and when. Things like anonymization and differential privacy are crucial for protecting people's privacy while still enabling the data to be used.
Finding that balance between using data and keeping things private is important.
Definitely. And that leads us to transparency.
Okay.
Especially with those more complex models, we need to understand and explain how they make their decisions.
So it's not enough for them to just be accurate. We need to know the why behind it.
Yes, especially for decisions that have big consequences, like with autonomous vehicles. Being able to explain the model's logic is crucial for trust and accountability.
Sounds like we need machine learning models that are easier to understand, especially when safety is involved.
Researchers are working on that,
Yeah.
trying to make those complex models more transparent so we can understand those factors behind the decisions.
That's good to know. But how do we make sure machine learning enhances human capabilities rather than replacing us altogether?
That's a big question we need to consider. Machine learning is a tool, a really powerful one, but still just a tool.
Mhm.
It's not meant to take over human judgment, creativity, or ethical decision-making.
So it's finding that balance between automation and human control, using the strengths of both.
Exactly. Machine learning excels with massive data, finding hidden patterns, and lightning-fast calculations. Humans are better with critical thinking, ethics, and understanding those complex situations.
It's all about collaboration, right? Machines and humans working together as partners.
That's the goal. A future where machines help us out, free us from those tedious tasks, and let us focus on the bigger decisions, creativity, and innovation.
I like that. What are some of the trends you're excited about in this field?
One that's really promising is combining machine learning with other technologies like edge computing and the Internet of Things. Imagine a whole network of sensors, vehicles, and infrastructure all connected and sharing data in real time.
Wow.
A level of awareness and responsiveness we've never seen before.
It's like a truly intelligent transportation system.
Exactly. And this will open up so many new possibilities for optimization, safety, even personalization.
Oh, wow.
Maybe personalized routes that adapt to you and the conditions, predictive maintenance to prevent breakdowns, even self-organizing traffic flows.
It's like the transportation system is a living thing, healing and adjusting itself.
That's a great analogy. I'm also excited about the focus on sustainability,
Yeah.
the environmental impact.
Oh, yeah.
Machine learning can optimize fuel efficiency, cut emissions, and promote those eco-friendly options.
So it's not just about speed and getting places fast. It's about being green, too.
Absolutely. Think about optimizing traffic lights to reduce idling and save fuel, planning better public transport routes, even encouraging electric vehicles and carpooling.
It sounds like machine learning can create a greener transportation system.
And that's something to work towards. It's not just about faster or easier. It's about sustainable, fair, and accessible for everyone.
Well said. This has been an incredible look at how machine learning is impacting transportation. It's changing how we move and connect.
And we've only just scratched the surface.
I know. But with all the excitement, we need to take a step back and think about the bigger picture. What are the implications of all this?
You're right, technology is powerful, but we need to use it responsibly. In our next segment, we'll dig into the ethical considerations, how this impacts society, and the importance of putting people first.
That's so important. We can't ignore that side of things.
It's a conversation we need to have. The future of transportation isn't just about the tech. It's about making sure it serves humanity. Join us as we explore those questions in the final part.
Welcome back to our deep dive.
We've covered algorithms, real-world applications, and now it's time to talk ethics. The big picture stuff.
Yeah, it's like technology is this powerful tool, but we have to be careful not to misuse it. It could make things worse or even create new problems we haven't thought of.
Exactly. Machine learning has the power to completely change transportation,
Yeah.
but we need to be cautious and responsible.
What are some of the ethical things we need to be thinking about?
Well, one of the biggest worries is something called algorithmic bias. These models are trained on data. And if that data has biases built in, the algorithms will just keep those biases going.
Oh, I see.
Could lead to some really unfair outcomes.
So like if a traffic enforcement system is trained on data that unfairly targets certain areas or groups of people,
Right.
it might keep focusing on those groups even if they're driving just like everyone else.
Exactly. We need to be really careful about the data we use, make sure it's representative, and that it doesn't have those hidden biases. We need things to be fair and transparent.
Makes sense. What about jobs? With more automation in transportation, what happens to the people who drive for a living?
It's a tough question. As we move towards automation, some jobs will be lost. That's inevitable. We need to address this head on,
Yeah.
investing in retraining programs, finding new job opportunities in those emerging fields, and supporting those who are transitioning.
So it's a shared responsibility, making sure everyone benefits and no one gets left behind.
Exactly. We need to consider the social and economic impact too, not just the tech itself.
Right. Okay, shifting gears a bit. How do we make sure machine learning in transportation puts people first? I mean, we don't want it to just be about efficiency, right?
That's a great point. It's easy to get caught up in efficiency, but transportation's about so much more than that. It's about connecting people, giving them access to things, improving their lives.
So it's not just about speed, but about a system that's safe, easy to use, accessible for everyone, and even enjoyable.
Exactly. Machine learning can help us get there.
Yeah.
But we need to design these systems with human values in mind. Things like accessibility for people with disabilities, how it impacts communities, the whole user experience.
It's a human-centered approach.
Right. We need to involve everyone in the conversation, the professionals, policymakers, communities, ethicists, working together so we create a transportation system that works for everyone.
And that brings up transparency. As these systems become more common, how do we make sure people understand how they work, how their data is used, how decisions are made?
Transparency is key. We need to be able to explain these systems, especially the ones that have a big impact on people's lives, giving clear explanations, letting people control their data, and having open discussions about the ethical side of things.
Building that trust and understanding is crucial.
Absolutely. It's not just the tech. It's how we use it to create a future we all want.
This has been an amazing look at the ethical side of machine learning. It's clear that it can change transportation for the better, but we have to be mindful of those responsibilities.
Yeah.
We need to ask the hard questions, talk openly, and work together to shape a future that benefits everyone.
Absolutely. The future is not set in stone,
Yeah.
We create it through our choices, our values, and how we choose to use technology.
This deep dive has been incredible. It's made me really think about the possibilities and the challenges ahead.
Yeah, an exciting time.
It is. We hope you've enjoyed this deep dive. Keep learning, keep asking those questions, and let's work together to create a better world through technology and innovation.
That's the goal.